Thank you, everyone, for attending today's webinar, Making the Case, How to Justify the Cost of a Rapid Prototyping System. I'm Leslie Langnaw, Managing Editor of Design World, and I'll be your moderator today. We would like to thank Kim Killoran of Stratasys and Todd Grimm, Founder and President of T.A. Grimm & Associates, for presenting this webinar.
Hello, and thank you for joining us for today's webinar, Making the Case, How to Justify the Cost of a Rapid Prototyping System. My name is Kim Killoran with Stratasys, and I will be your host for today's event. For those of you who aren't familiar with our company, Stratasys makes additive manufacturing systems that produce prototypes and production parts directly from 3D CAD files. We also operate Red-Eye on demand, an online rapid prototyping and digital manufacturing service. All of the Stratasys systems and services use our patented FDM technology, which extrudes thermoplastics layer by layer to create a part from a digital file. This technology allows users to build real working models that they can see, feel, and test. By modeling early and often throughout the design process, you can find flaws early when it's least expensive to correct them. FDM parts are used for concept models, functional prototypes, manufacturing tools, and even end-use parts. In just a few seconds, I'll introduce our speaker, but just one quick final note. Today's webinar is a summary of a white paper that we just completed, so everything you're going to hear in the webinar and more is available in this white paper, which you will be able to download after the presentation. The presentation contains a lot of information and will move pretty quickly, and because of this, feel free to sit back and enjoy the content without worrying about note-taking, since the white paper will basically be able to take place of any of your notes. Now I would like to introduce our speaker, Todd Grimm. Mr. Grimm is an industry analyst and consultant in the additive manufacturing industry. He is an author and a public speaker, and he has 20 years of experience in the world of design and manufacturing. Welcome, Todd.
Thank you very much, Kim. Well, additive manufacturing, that's a term I'm going to use throughout this presentation. It's also synonymous with rapid prototyping. But additive manufacturing justification is kind of an interesting procedure. If you're at the point of making a proposal because you want a system, you've already discovered the tremendous value in time, in cost, and in product quality. And you've probably become so in tune to those values that it seems obvious. The value is just so enormous, so obvious in the area of time, cost, and quality, or better, faster, and cheaper, that it's hard to believe that others can't also associate to that and use that in a proposal or justification process. But there's actually a challenge, and it's the reason you're probably sitting in on this webinar. Although we have better, faster, and cheaper coming out of rapid prototyping or additive manufacturing systems, it's hard to quantify those numbers. It's often hard to make an if-then or cause and effect kind of a relationship between what the technology can do and a financial output or outcome that you can justify on. Another challenge you may not have thought of is that it's difficult, or can be difficult, to put the justification into words. Actually, I should say the proper words. How do you tell the right story? How do you use the right language? And how do you use the right level of detail? Those are 2 points that I want to cover in today's webinar in order to help you get to yes, to help you get an approval for the additive manufacturing system that you're looking to secure. I'm going to do that by describing the business case, describing what it is, why it's important, what it includes, and give you some tips and tricks along the way on how to construct one to get to yes. Now, I'm going to do this all through the eyes of Joe. He's our fictitious engineering manager who works for a fictitious company called Telco that sells $50 million a year in cordless telephones. Now, Joe has signing approval or budgetary approval up to $5,000. Since his additive manufacturing system is going to cost more than that $5,000 price point, he now has to step up to a much higher level. He's got to compete for funds out of the corporate capital expenditure budget. And the tool he uses to compete for those funds is the business case. Simply put, it's a report. It's a report that summarizes what you want to do, for example, buying an additive manufacturing system, and then puts information to that with regards to the value that you'll gain when you get the system, any risks that you could possibly encounter, and also the total investment required. Now, at a minimum, the business case includes an executive summary, a situational analysis, which is comprised of the current challenge and opportunity, a statement of the proposed solution, a statement of the alternatives, and a statement of the risk. The last section is the financial or cost justification. Now, when you put all that together in a business case, it gives the decision maker, most likely one of your executives, enough information to weigh the investment, to decide if it makes financial sense to move forward. So that business case, standalone, should give them enough information to decide whether to accept, reject, or suggest additional investigation of your proposal. Now, I'm going to offer the first tip, and that is to seek help and guidance, because I've identified the sections in the business case that you should include. Well, those will change with each and every organization. Also, the metrics or financial measures that you use can differ from company A to company B. So anytime you venture into one of these, find someone who's done it before and has succeeded. Or more importantly, go to your accounting department. Find the people that are responsible for cost accounting, seek their guidance on how to develop a business case and to discover what financial metrics to use. Well, with all that preamble, let's move to the first section, the executive summary. We'll actually move to tip number 2 right off the bat, and that is to be succinct. Instead of that stack of paper, that huge stack of paper in the image, I want you to drive that down to a small report. Maybe even something smaller. A few sheets of paper that fit into a portfolio would be ideal. So you want to state the business case as concisely as you can, which is a challenge because Joe, our engineer, has an engineering mentality. He wants to go for all the detail and have this huge report that covers all bases. That's the wrong thing to do. You want to be as concise and succinct as possible, yet get across the message. Tip number 3 is to be compelling. So you got to be succinct and concise, yet tell a compelling story. The 2 elements of a compelling story are, number 1, talk to the business issues of the decision makers. Don't talk to the issues of the engineering department, for example. Drive it up a level and hit the hot buttons that management is most concerned about. The other thing to do is to use their language. Instead of speaking engineering language and using engineering jargon, engineering terminology, drive that down to their language, them being the decision makers or your management, which most often is the simplest and best bet is going to be talk in terms of profit and loss. Talk in terms of numbers. So with those 2 tips, well, let's look at the executive summary. It is critical. It will make or break your business case. Imagine it's almost synonymous to an online book summary at Amazon.com. If that book summary does not hook you, you'll move on and never think about buying that book again. But if it does, you may decide to buy the book immediately or look at all the reviews to decide if it's worthwhile purchase. It's a standalone item. It is not an introduction. So in this executive summary, you want to concisely state, succinctly state the challenge that you're addressing, the solution you're proposing, the investment that will be required, and the return that they will see when it's implemented. And when I say succinct and concise, I mean 2 or 3 paragraphs. That's it. That's an ideal executive summary. In a sense, some call it an elevator speech or elevator pitch, something that you can deliver to that busy executive from the time the elevator doors open to the time you reach your destination floor and exit that elevator. It should be that concise. So really, and that it's not an introduction, it's a standalone element that tells the whole story. Your executive summary should highlight all the highlights that follow afterwards, and always emphasize the numbers. Now we'll move on to the situational analysis. The first section is the current situation. And throughout the situational analysis, the same philosophy applies. You're going to add more information and more detail than in the executive summary, but not that much more, because each of the 4 sections should be limited to 2 to 3 paragraphs. Keep those concise also. Well, the first one is the current situation, the diagnosis, if you will. This is a statement of what's going on in your corporation, the challenge or opportunity that you face. You clearly state that challenge or opportunity and identify who's affected in the organization and how. Along with that statement, you want to focus in on what the justifiable aspect is. And what I mean by this is it's very tempting to sprinkle in all kinds of situations that additive manufacturing can solve, but that only muddies the waters. Instead, if you can, stick to one justifiable point, the thing that you use in your financial justification. So for example, if you're building your justification on cost reduction, savings, Don't sprinkle in liberal amounts of increased sales just to do so to make the pot sweeter. Keep it focused. And keep it focused on the numbers. Just as with executive summary, use the numbers liberally. Now for our example of telco, Joe's numbers look something like this. Now the first two, sales and R&D, that's for your benefit. It has nothing to do with the business case. As I said, telco's $50 million in sales, and their product development, I'm calling it R&D here for to have a short abbreviation there. That whole budget is $2.5 million a year, 5% of sales. The two numbers Joe will use in his business case are prototype expense and ECOs. ECOs standing for engineering change orders, which loosely using to cover all the costs associated with late cycle changes. Joe's detected that on an average year, they spend $80,000 a year on outsourced work for prototype and pattern development. $75,000 for prototypes, $5,000 a year for patterns. The engineering change orders is an issue that just cropped up at Joe's company because they had some consultants come in and discover that they're wasting $50,000 a year with late cycle cost related to change. So this covers everything from redoing CAD databases and drawings and disseminating that information, reworking tooling, etc., etc. So these are the two elements that Joe's going to base his business case on, which takes us to the proposed solution. This is the treatment, if you will, to the diagnosis we just made. And of course, in our case, the proposed solution is an additive manufacturing system. In Joe's case, he may be looking at buying a Stratasys Fortis machine, for example. So in the proposed solution section of the business case, he now states specifically what it is he wants to do: buy an additive manufacturing machine. He states the total investment to get that system operational, and then also states the implementation time. So from the time he releases a purchase order or signs a contract to the time that it's fully operational, he tells management how long that'll be. The other thing he states very clearly, and here's where the meat of the business case happens, he details the benefits. I'm going to offer a tip here. State the end results. When you're talking about the benefits, don't stop short. What I mean is you want to drive it all the way down to the most fundamental financial number you can get to. So for example, if he was proposing an additive manufacturing system and making the claim that there would be labor reductions of 5 hours a week in engineering department, he wouldn't stop at the 5 hours a week, because now management is left to wonder, what are you going to do with those 5 hours? Is he going to play more solitary, go home early, or are you going to use it to not hire a temporary employee, or are you going to use it to not hire that full-time employee next year? So drive it all the way down to the not hiring a temp or not hiring a full-time employee next year as an example. I'm not talking about building your case on labor reduction. That's just an example. Also, in the situational analysis, the proposed solution, lead with the hard numbers. That challenge we talked about in the beginning. You've got to get to those. So stress the hard numbers, the tangible, measurable, hard numbers that you develop in your cost justification. But it's okay, and actually I recommend referencing the softer or intangible gains. So a statement along the lines of, we will save $100,000 with this additive manufacturing system, and then, oh, by the way, we're also going to be able to do prototypes in a day instead of 5 days. Use that second unqualified benefit as kind of a value-added statement, something that puts the whole proposal over the top. Now for Joe, his numbers look like this. His system, and we'll develop, I'll show you how these are built out later. The additive manufacturing system is $105,000. Ongoing expenses each year is $34,000, and Joe's going to show the company a savings of $75,000 a year. That's what he would put in his situational analysis for the proposed solution. The next two sections are much briefer. The first is alternatives. You want to list all the, I shouldn't say all, you want to list the alternatives that you considered in conjunction with the additive manufacturing system you're proposing. So for example, it may be other additive manufacturing systems. It may be building a machine shop within the organization, or getting some volume discounting from your current supply chain. Those are good examples of alternatives. You list those, but you quickly dispatch them. You dispose of them with a short statement, hopefully one sentence that says it wasn't ideal because, and you fill in the blank. Now with this, I've got another tip for you. For alternatives, list only the obvious alternatives. Don't be a Joe and list every single alternative you considered since the time of the evaluation began. There's two reasons. First off, if you list all these alternatives, you're likely to create your own objection. Someone looks at something and says, oh, I didn't think about that one. Maybe we should pursue that. And second, if you don't have all the alternatives listed, it gives the decision makers a chance to put your feet to the fire, if you will, to test you. They can ask, well, you haven't listed this as an alternative. Did you consider it? And then in a face-to-face discussion, you reply, well, yes, we did. Didn't include it in the business case, but we did, and here's why we didn't choose that one. So list the obvious on the alternatives. Do the very same thing for risks. Don't list everything. List the obvious risks. One example for risk would be for additive manufacturing with a rapid pace of change of technology. You might list a risk of obsolescence and then quickly dispatch it by stating that the technology I'm looking at, there's systems out there that have been operating for the last 15 or 20 years and are still operating. So you quickly dispatch the risks. That's the situational analysis, which now takes us to the financial justification. You've got two paths you can go after. You may have, in some cases, you may have to go after both cost reduction and revenue increase, but I highly recommend you stick to one of the two paths in your justification to stay focused, to hone in on that one aspect. And I'm also going to recommend that you go after cost reduction as the preferred method, at least to start. The reason is, cost reduction in today's economic times usually at the heart of the matter. People are looking more for savings than growing businesses in general. Also, the finance department, which will be a part of this approval process, typically warms up to cost reduction faster than they do projections of increased sales. And finally, cost reductions, you're going to have more items that you can find hard, tangible numbers that aren't nearly as speculative as if you go after revenue increase. Now, if there's corporate initiatives that are looking at global growth or growing the company by 200, 300, 400%, certainly you would go after revenue increase to support your initiatives. But in general, I'm going to recommend going after cost reduction. And in the financial justification, there's two parts. There's the outflow and the inflow. The outflow is the initial capital expenditure and then also the ongoing cost to have the machine operating year to year to year. And on the inflow, you have your return or your value. This is the financial gain. We'll start with the outflow first. For your investment, you want to include all of those items, all the cost of those items to get the system operational. So that's going to be your system. It'll include ancillary equipment on the front end and back end, computers and part washers, for example, licenses for software, installation and training, shipping, IT expenditures, maybe for some networking, facility modifications. You might need some utilities, some more power or other items. You want to include all these items in your initial investment. This isn't too hard. It's pretty obvious here, but you do want to do your homework. Nothing's worse than having a proposal approved and then going back to the well for more money because you missed an item. So do your homework here, be thorough, but you'll be okay. For Joe, his initial investment looks like this. The additive manufacturing system itself is $90,000. The equipment and licenses needed to run that machine are $8,000, and installation and training are $7,000. That total is $105,000, which is the number I referenced earlier. Now for ongoing expense, this gets a little more difficult. These will include everything that you will have an outflow of cash on a yearly basis, whether the machine's idle or not, but also when you're running the machine. So this will include maintenance contracts, time and material for routine maintenance, materials and consumables for all those parts you're going to build, any labor associated with running the machine. And here I want to recommend that you try to keep things simple. Only include labor if your company will allow you to, and if your business case is built this way. Only include labor if you've actually got to add someone. If you're going to take an additional hour or two out of the engineering staff's time, but it's going to be handled by the current staff load, don't include it. Finally, facility charges. Bigger organizations, you might run into some facility charges for the actual floor space that you're using. Now these get a little bit involved, and you can't develop them until after you've started to develop the return side, the inflow side, because many of these numbers are dependent on the number of parts you're going to build, how many runs you're going to have of your additive manufacturing machine, how many parts you'll build, all of those details. So you got to work out the return side first before you do the investment. Also, there's going to be numbers in here that unless you've run these kind of machines before, that specific machine that you're looking to secure, you won't have information on how much time it takes on the front end and the back end, and and elements that only a user would know. So you're going to have to turn to your reseller or the vendor to get some of these details. Now, with that said, I'm going to go ahead and present some numbers for telco, just to keep the linear nature of this business case going. So for telco, what Joe has determined is he's going to have a maintenance expense on his machine of $15,000 a year to build all the parts that he's planning to build. Parts and consumables, or materials and consumables associated with that will be $12,000, and then he does have $7,000 a year for labor. This is for some part-time assistance for post-processing parts. So he actually is going to bring in a part-time person on top of those that they already have on their payroll. So now we start building our financial template. At the top we have the analysis summary, which are some of the key or possible metrics used for a business justification. I just got dashes in there because we don't have enough information to calculate these yet. At the bottom, our table shows year zero. That's our initial investment, the $105,000 for the system. And then in years 1 through 5, we've got $34,000 of expense for the ongoing expense of the machine. Second row from the bottom is the total. So that's the total for each year. So $105,000 the first year, $34,000 each year after. And then the bottom line is the cumulative total. It's adding up all those expenses all the way out to year 5. So after 5 years, Joe would have invested, his company would have invested $275,000. Now let's turn to the benefits side, the returns. The whole premise of this webinar is that it's very difficult to establish this if-then cause-and-effect relationship between time, cost, and quality that additive manufacturing can affect and put that into quantifiable terms. So, for example, additive manufacturing is all about speed, but what do 2 weeks really equal? How much value is there? How much financial value that you can put in tangible form and quantifiable numbers is there? Well, it's tough to come up with that. So I'm recommending to Joe, and I'm recommending to you, a 3-tiered approach. What it does is takes tiers 1, 2, and 3, moving from the hardest, most tangible, quantifiable numbers off to the softest at tier 3. I'm also recommending that Joe go through an iterative process. So he starts off with a first cut, a first revision, sees how those numbers looks, and then modifies those to get to the point of where he has a compelling argument and a strong financial case. So go through tiers 1 through 3 and do an iterative process. Tier 1 will be based on the savings that's very tangible of moving existing prototype work or parts development from other sources to your additive manufacturing machine. So once it's installed, we're now going to migrate these parts to our new technology. And there's going to be 2 sources. There's going to be outsourced, so the stuff you're doing on the outside, and that will come from, potentially, depending on your organization, outsourced work you're already having done through additive manufacturing, through service bureaus, for example, but also conventional work. You want to look for all those parts that are being machined or molded or cast that could be done on your machine. In-house means exactly what it sounds like. If you happen to have an internal model shop or machine shop or capabilities to build parts, you also want to look there for any parts that could be migrated to your machine. Now, Joe doesn't have this because they shut down their internal model shop about a decade ago in the last recession. For these 2 sources, now what you want to do is you want to go back, do a look back over 1 to 3 years. So 12 to 36 months would be recommended, and you want to collect all the data you can for all of the parts that have the possibility of being migrated to your additive manufacturing machine, with the caveat that you're looking for parts that, looking forward, will also be done for years 1 through 5, so they'll be repeated and to the same degree, same level. So for outsourced, fairly easy. You look through all your invoices or purchase orders, whatever document you want to look through, and you calculate or you sum up, total up all the numbers for the part cost, any engineering costs, any labor cost. You add in any expedite fees. Every single penny that you spend on the outside for these parts, get it into the bucket. Complicated. If you're a larger organization and you happen to have internal cross charges, meaning if you have a part machined, you actually get an invoice, a pseudo invoice from that department that your department has to pay. Well, you use the very same methodology as you did for outsourced costs. Add up that invoice amount. That doesn't happen nearly as much anymore, especially for small and mid-sized businesses. So here you're really going to have to turn to the cost accountants. You're going to turn to them to figure out how do you quantify how much it's really costing to make those parts, therefore how much savings, but also to help you determine if that is a savings at the corporate level. What I mean by that is if all you're doing is moving a prototype from one department to the other and there's no change in the original department, eliminating some equipment or taking on new work, higher level work, well, there's no net effect for the corporation, so it wouldn't be any benefit. So with that, seek help from the cost accounting or your accounting and financial department if you have in-house possibilities. Don't be like Joe. Joe wants to document every single line item in great detail. You'll drive yourself crazy, and management doesn't want all that detail, so what you want to do is start building buckets. For his handsets, what I'd recommend to Joe is he has a bucket for, or his telephones, for the handset parts, another bucket for the base station, so the upper and lower bezel and the mounting bracket, and then another bucket for all the other small plastic parts. Within these buckets, now you start looking for averages. Averages in terms of cost, averages in terms of time, averages in terms of labor, averages in terms of how many parts are purchased each year or with each product or with each revision. So you're simplifying. You want to make this as simple as possible, but you do have to document everything. Make sure you have enough documentation so you can support your claims, and also if you have to rework this information, you can go back and do it again. So for Joe, what he has figured out, or what he has determined, is that he can save $60,000 in prototypes. As I mentioned, he had $80,000 in expense for outsourced prototypes and patterns. $75,000 was for prototypes, $5,000 was for patterns. Well, he's conservatively stating that he can bring in-house $60,000 of that $75,000, so he didn't have to spend that money anymore. For patterns, he's saying he can do all of it on his new additive manufacturing machine for a total of $65,000 a year savings. Now we drop that into our financial template. So now we've got a new line for the return right in the middle of that lower table of $65,000 a year, the number we just calculated. Below that is the total. So now we have the total net gain for each year. So $105,000 for the investment stays the same. But now years 1 through 5, we have a $31,000 positive return based on having the additive manufacturing machine. And now the cumulative total is the ongoing accumulation of the total expense and gain. So that shows us at year 4, we've now broken even. We've got $19,000 in quote-unquote profit. In year 5, $50,000. So we're looking pretty good. We go up to the top to the analysis summary. These numbers aren't too bad. Return on investment over 5 years of 48%. Simple annual ROI, which is just that 48% divided by the 5 years we're calculating over, 10%. Internal rate of return, 15%. Net present value, minus $1,000. That's really a wash. Just call that 0. That's okay. And a payback period of 46 months, which, according to the accountants that I've talked with, on equipment like this, capital expenditure, a payback period of 3 to 5 years is ideal. So our numbers are all okay, but Joe feels that he doesn't have quite the compelling case that he needs. These numbers aren't quite strong enough. So he could go back to Tier 1 and look for more parts, but he's electing to go to Tier 2. And Tier 2 is all about increasing the number of prototypes or patterns or parts that you're building. So it's moving forward and doing more because you have the ease, the convenience, the efficiency, and the lower cost of the additive manufacturing machine in-house. So you're doing more prototypes at the same stages, so more iterations, and also more prototypes at other stages in the product development process. Now the problem or the challenge is, how do we equate that to a number? And what I'm going to recommend to you and to Joe is to leverage generally accepted values. Find things in your organization where everybody, no one doubts, everyone agrees that if we do a part here or if we do a prototype there, this is what we can expect as an outcome. Now I'm going to show a scrolling list of some of the ideas that start coming up here. Don't try to remember in the white paper, and then just to give you an example. And you're going to find your own too within your organization. But finding errors so you have less tooling, errors so you can get to market faster after a problem. Increasing sales, perhaps more prototypes allow you to do more frequent product launches. So those kind of things are the benefits of prototypes in general, but now we're going to associate those to additive manufacturing by establishing given kind of a cause and effect relationship. So management, the whole company, believes that if we do parts here, it saves us somewhere on the backside. Find those, and now you set yourself up with some kind of equation where you say if then, so 1 plus 1 equals 2. Using that logic, now you state that because additive manufacturing makes it more convenient, easier to do the prototyping, we're going to increase our volume by X, and then you use that number that's generally accepted to come up with a value. In Joe's case, I think you know where I'm going, it's engineering change orders. They had the management consultant come in, said they spent $50,000 a year, they wasted $50,000 a year because of late cycle design changes. Joe's going to be conservative. He's going to state that they can do more prototypes with the additive manufacturing machine, and he believes, or not believes, he is stating that we can shave off 20% of that wasted expense by having the technology. So simply $10,000 a year. Now we add that in our return row to the $65,000 before. Now we have $75,000 a year savings. We still have our $34,000 outflow each year, so we have a net or a total of $41,000 a year financial gain. And a cumulative total, we now in year 3 break even, we have $18,000, and out to year 5 we now have $100,000 financial benefit. Now we've got some very strong and compelling numbers. Up in the analysis summary, an ROI of 95%, internal rate of return of 27%, very attractive. Net present value, $32,400, very attractive. And a payback period of just shy of 3 years, 31 months. Those numbers work. He now has a compelling argument in his business case. And if you don't know what each of these terms mean, don't worry. Again, seek advice, seek guidance, go to your accounting department to get some instruction on how to calculate these and what they mean. Since Joe doesn't need Tier 3, but I'm still going to talk through that so you have some idea of what to do if you still need value in your justification. And here we're talking about those softest, least tangible gains of additive manufacturing, and the one that jumps to mind is speed. That is what the technology is known for. That's what it does extremely well, but it's the hardest thing to apply a dollar amount to. This race car here, which epitomizes speed. If I were to try to justify buying this race car because it can get me to work faster so I can make more overtime money and therefore have more income per year, just because the car can go 200 miles an hour doesn't mean that I'm going to get to work any faster. I've got stoplights and commuter traffic in the way. So that if-then relationship, the cause and effect, breaks down and people can shoot it down and negate it. That happens with speed in additive manufacturing. Just because you can get parts 2 weeks faster does not translate to reducing your time to market by 2 weeks. So, my recommendation to Joe to work to associate time to money is to omit it from his calculations. If at all possible, keep it out of the hard numbers, the financial justification, but don't ignore it. Remember in the proposed solutions section, put in the intangible items as value add. So again, in Joe's case, he now has $100,000 over 5 years. In his proposed solution section, he would also make that statement. And by the way, we have that tremendous value, but at the same time, we're going to be able to do prototypes in a day versus 5 days, which is going to allow us to respond to emergencies, to surprises, to problems much, much faster and be a better company for it. But if you need to use this calculation, one idea is to locate something in your process that is a gating factor, meaning that if it accelerates or if it lengthens, the whole cycle lengthens. So there's nothing else that controls it. Find those items, usually late in the cycle, that then can have additive manufacturing applied to them to give you some time benefit. So what you're really doing is isolating something that no one can dispute, that if you accelerate it, it's going to be faster, and then find the associated value with that acceleration. It could be cost, it could be additional profit, but you now make that connection. So in my race car analogy, it might be one where the last stretch is a 60 miles straightaway, and let's assume there's no police cars. Maybe the race car does make sense, because I can hit 200 miles an hour, again, if there's no police officers, for that last 60-mile stretch, and therefore I can get to work faster. That's the kind of logic you may want to use. But again, Joe didn't need to, so we're back to the very same numbers. I'm bringing this table up just to highlight in the telco burnt orange the numbers that you will now use throughout your situational analysis and executive summary. So to recap, work those numbers, the financial justification, through an iterative process, many revisions to keep coming up with numbers that work. And also use Tier 1, Tier 2, and Tier 3 to move through your hardest to softest benefits of additive manufacturing. Roll that up, use those numbers liberally throughout your situational analysis, which includes the current situation, proposed solution, alternatives and risk, and finally, roll all that up into a nice, tight, concise, succinct statement in the executive summary. And reiterate my hints from along the way, be concise yet compelling. Get that story across succinctly, but in a way that gets attention and has people wanting or agreeing that this is the best thing to do. Be compelling yet realistic. Never go over the top. Have numbers that are hard to argue with, that are defensible. Finally, be realistic and tangible. Always work to get to that very tangible, very measurable, very quantifiable number. With that, I hope it helps you get to yes for your additive manufacturing system. And I will conclude by turning the presentation back over to Kim.
Great. If you have a question, be sure to submit it through the chat panel now. In just a minute, Todd will answer some of the questions that have been coming through during the presentation. Before we take the questions, though, I'd like to make a quick plug for the additive manufacturing systems from Stratasys. Stratasys is actually the only manufacturer of additive manufacturing systems that produce real parts from engineering-grade thermoplastics. If you make plastic products, prototyping with the same materials allows you to best predict your end product's performance. Using these dimensionally stable materials, the thermoplastics, FDM can achieve tight tolerances. Because of this, more and more manufacturers are starting to use FDM to make production assembly tools like jigs and fixtures, and many are even making low-volume production parts. To download a copy of the slides, and for additional information, like the white paper that we mentioned, you can go to www.stratasys.com/cost justification. There are additional materials on there as well. You can request a sample part and other things that will be helpful when trying to make the case for purchasing a machine. Also available is a customer story on the snowmobile manufacturer Polaris. The case study shows how Polaris brought in FDM technology to reduce tooling costs by 98% and lead time by 97% for a snowmobile carrier rack. Please note this is not a necessarily specific case study to justifying a machine purchase. It's actually an application profile on how Polaris uses the technology in its prototyping process to perfect designs before going to tooling. So the savings don't necessarily represent actual return on investment. So during the presentation, it looks like a couple questions have come in. We have a little bit of time to take those live now. So, Todd, let's look at this question. It's from Bill, who asks, is return on investment the same thing as return?
That's a really good question. To a lot of people, the answer is yes, but that's actually inaccurate. Some people use those two as synonyms and just interchange them, but return is a dollar amount. It's the financial gain you have. Return on investment is a percentage. It's actually a formula, an accounting formula that's very, very specific that yields a percentage of return. It's the net gain divided by the initial investment. So no, they're not the same thing, but people do use them interchangeably, incorrectly. Okay,
thanks, Todd. Here's another question that came in. This one is from Susan. What is a capital expenditure?
Excellent question, too. I should have actually explained that early or defined that early on. Capital expenditure is they're the long-term assets. So I believe the official definition is anything it's on the financial books that's usable beyond the current financial year. Typical examples are buildings, plants, land, equipment, and machinery. So it's the big expense. It's the larger ticket items that the company will be using for a number of years.
Okay. Here is another good one. Terry asks, does the three-tiered approach work for manufacturing applications as well?
Let's see here. Manufacturing, I think I know what Terry means, but let me split one hair first. There's an aspect of manufacturing applications that I really enjoy, which are jigs and fixtures and other tooling-related things. In that case, yeah, the model works perfectly, and you may find that you'll have return on investment, huge returns on investment by making those in-house instead of going to conventional machine shops. But I think Terry's probably talking about production parts or end-use parts, and you can build off of the strategy that I have and some of the ideas, but it doesn't map exactly. You can't use the model exactly for manufacturing parts. Key reason is you're going to get into more of a head-to-head cost per unit cost comparison of one process versus the other, which is really clearly defined and somewhat easy to do. The challenge is going to be you're going to have to apply a value to making parts in lower quantities, because additive manufacturing, as most people realize, is not ideal for larger volume production. So you may have to find a way to put a dollar amount to making smaller batches of, say, custom parts. So similar, long-winded answer. It's very similar. You can pull from some of the same concepts, but it is a little bit different of an animal.
Okay, that makes sense. Here is another question from someone, ironically enough, also named Joe. Can I use the same approach to justify a second or a third machine?
Probably not. The reason is we've so heavily based it on the Tier 1, which is pulling parts from other sources on your additive manufacturing machine. Well, if you've already consumed all that and you're doing everything on your machine now, Tier 1 goes away, so you're going to be relying on the Tier 2 stuff. But one advantage you have, if you document, is that you can put you can make all the value of reducing tooling rework, reducing the cost for modifications and revisions. You can make that tangible if you document. So what I mean by that is, as soon as you get your machine up and running, start documenting any major situations where you had some parts produced and they help you detect an error that prevented you from going to tooling too early, which would have cost $20,000 in tooling rework, that sort of thing. So document that, and now you'll have very tangible examples to justify your machine on.
Sounds good. It looks like we probably have time for one more question. Darren is asking, is there any other way to show the value of time?
That's a great question, Darren. The one thing that jumps to mind is if you want to go after a labor component, you can. I like to translate time into efficiency. So if you're looking at time in terms of the time it takes an engineer or designer or manufacturing engineer to execute a prototyping activity, you can turn that into real dollars, real cents, but it does get you into that incremental conversation of now are we adding people, removing people from our head count. You can also look a lot harder at the time to market issue. If you use a similar strategy but go late in the cycle for something that you definitely have a situation where if you decrease that time for that process, you'll get to market that much faster. That's a great calculation because the numbers are huge, and sales and marketing will have already determined what your annual or daily sales are going to be, so you can use it that way. But the bottom line is it's so hard to say. It's going to be very unique to each company. So back to the writing the story for the decision makers, the issues of their day. Well, with regards to time, my best recommendation is look around your organization and see if there's any time-related issues that you can leverage. You might find that the company is all about reducing time to market, and that's the number one initiative. And if so, you may be able to just easily show in an executive summary that additive manufacturing can help them get to that goal, and you might be done with just an executive summary and showing that that it can help play that role. So it's very, very personal, very company specific. I wish you luck. Just look around, keep asking questions, and try to find your own connection between time and value.
Great. Thanks, Todd, and thanks for your presentation and your answers. If we didn't get to your question on the call today, we will follow up with you via email afterwards. We'd like to thank each of you for your attention during this presentation, and now I will turn it over to our operator who will close out the session.